Nicotinamide mononucleotide (NMN), as a precursor to NAD+, holds growing promise in the field of metabolic and inflammatory aging. Beyond its well-documented roles in energy metabolism and mitochondrial function, NMN may also serve as a powerful modulator of chronic inflammation, particularly the low-grade, persistent type that accumulates in aging tissues and contributes to both metabolic dysfunction and the expansion of unhealthy fat stores. One of the central mechanisms through which NMN may exert these anti-inflammatory and anti-adiposity effects is the enhancement of autophagy, the cellular process responsible for degrading and recycling damaged organelles, protein aggregates, and inflammatory mediators. In this context, autophagy is not only a housekeeper but also a peacekeeper, helping to suppress unnecessary immune activation and maintain adipose tissue homeostasis during aging. With age, adipose tissue becomes inflamed, not just due to increased fat mass but because of qualitative changes in the fat itself. Senescent cells accumulate in fat depots, secreting pro-inflammatory cytokines like TNF-A, IL-6, and MCP-1. These factors recruit immune cells such as macrophages, which often shift from an anti-inflammatory M2 to a pro-inflammatory M1 phenotype. This inflammatory state disrupts insulin signaling, encourages ectopic fat deposition, and further impairs mitochondrial function, creating a vicious cycle that accelerates metabolic deterioration. Autophagy is one of the few intrinsic mechanisms capable of breaking the cycle, as it helps remove senescent cells, dampens oxidative stress, and supports a more anti-inflammatory cellular environment. However, autophagic activity declines with age, precisely when it's needed most. By restoring NAD+ levels, NMN reactivates key autophagy-regulating pathways, particularly those involving SIRT1 and AMPK. SIRT1 not only promotes autophagy by deacetylating autophagy-related proteins, but also directly suppresses the expression of inflammatory genes through inhibition of NF-B, a master regulator of inflammation. Through this dual effect, stimulating cellular cleanup and silencing inflammatory signals, NMN helps recalibrate the immune balance within adipose tissue. Experimental models have shown that NMN administration in aged and obese mice leads to a measurable reduction in inflammatory markers within white adipose tissue, accompanied by an increase in autophagy-related gene expression and improved insulin sensitivity. These findings suggest that the benefits are not merely metabolic but also immunological in nature. In addition to suppressing local inflammation in fat depots, NMN-enhanced autophagy may reduce systemic inflammation that affects other organs, including the liver, muscle, and brain. The reduction of circulating pro-inflammatory cytokines following NMN supplementation appears to correlate with improvements in glucose tolerance and lipid metabolism, suggesting that autophagy helps normalize interorgan communication that otherwise becomes distorted in metabolic syndrome. Mitochondrial quality control also plays a part. By promoting mitophagy, NMN helps eliminate dysfunctional mitochondria that would otherwise generate excessive reactive oxygen species, ROS, further amplifying inflammation. This mitochondrial cleanup contributes to a broader anti-inflammatory effect, helping to restore cellular energy balance and reduce the inflammatory burden system-wide. One particularly important aspect of this anti-inflammatory, autophagy-mediated effect is its influence on the immune cells that reside within adipose tissue. Autophagy regulates the activation state of macrophages and T cells, pushing them toward a more anti-inflammatory, regulatory phenotype. By improving autophagic flux in these immune cells, NMN may help shift the inflammatory tone of adipose tissue, reducing the chronic immune activation that drives insulin resistance and adipocyte dysfunction. The result is not just less fat, but healthier fat, more metabolically active, more insulin sensitive, and less likely to spill over into visceral organs where it causes further damage. While human studies on NMN's effects on inflammation in adipose tissue are still in early stages, available data show encouraging trends. NMN has been reported to reduce markers of oxidative stress and systemic inflammation in older adults, along with improvements in vascular function and physical endurance. These benefits align well with the mechanisms seen in animal studies and support the hypothesis that NMN-induced autophagy may help mitigate the chronic, smoldering inflammation that underpins much of the metabolic decline associated with aging. In sum, NMN represents more than just an energy booster. It is an upstream regulator of immune balance, fat health, and tissue resilience. By enhancing autophagy, It unlocks a latent anti-inflammatory capacity within cells, helping to dismantle the cellular debris and immune noise that build up with age. This makes NMN not only a promising tool for managing obesity and insulin resistance, but also a potential therapeutic agent in the broader fight against inflammaging, the chronic inflammation that accelerates aging across multiple organ systems. As the science continues to evolve, NMN's ability to leverage autophagy as a mediator between metabolism and inflammation may become one of its most important and far-reaching benefits.